Good afternoon or good morning. Thank you for joining us for today's webinar about reaping public cloud benefits, even when you can't just move everything into the public cloud. I'm happy to have Cloudistics here with us today, along with Actual Tech Media. We are here to present you with some educational information about some of the future things you're seeing in IT that you can get today. And we want to make sure that you are operating your data centers in as efficient way as possible. And to that end, I'm joined today by Mr. Steve Connor, who is the Vice President of Sales for Cloudistics. Steve, thank you for being here today.
Thanks, Scott. I appreciate you having me.
And I'm Scott Lowe. I'm the partner and CEO of Actual Tech Media. And we're thrilled to be talking to you today about the cloud. Specifically, we're going to focus on the private cloud. But in order to do that, we have to have some context around what cloud means. So we're going to start by talking about why the public cloud has become so popular. And then we're going to talk about some myths and misconceptions around the private cloud, things that people think about when they hear the term private cloud that may not always be wholly accurate. Then we're going to look at, when we start to look at private cloud infrastructure, what I call the infrastructure spectrum, basically some of the things that you have as far as options go in your data center. And we're going to end that portion of the discussion with a chat about what's called composable infrastructure, which is really a step beyond a lot of the solutions that are available or have been available on the market traditionally. And we're going to then talk to Cloudistics. Steve Connor will be talking to us about the Cloudistics on-premises cloud platform. Then we're going to wrap up with a demo and Q&A from Cloudistics. So it's going to be a jam-packed agenda today, and we're going to get started pretty quickly here. One of the things to bear in mind is when we start to think about the cloud, it's really a journey, not always a destination. And what that means is we're not necessarily looking for public cloud. You know, when we have decision makers come in and say, we need to do cloud, they've probably, heard the public cloud mantra. They've heard Microsoft commercials saying to the cloud. They've heard about all the really cool things you can do financially with Amazon AWS. But they're looking for something a little bit different. You know, they might say, we got to push everything to Amazon and Azure, but they're really looking for the outcomes. What can the cloud actually provide them? They're not necessarily looking to just dump everything in the cloud. One of the big things that people are looking for is this transition from significant capital expenditure to more of an OpEx operating model. And that's one of the reasons they're looking at cloud. And when we look at traditional infrastructure, it can be hard to get out of this CapEx model sometimes. We're also looking for overall reduced total cost of ownership. We want to be able to operate our data center environments, our workload operating environments more in a way that's more fiscally sustainable than we may have been able to do with traditional infrastructure. We're also looking for faster return on investment and time to value for our data center infrastructure investments. One of the biggest challenges for organizations is when they start to buy a whole bunch of stuff in the data center, if it can't get up and running within a few weeks, then there's really a cost associated with that. And so this idea of faster time to value is something that I think is pretty important. Oops, I hit the wrong button, sorry. And so what we're looking for really are cloud-like outcomes. So Steve, when you think about this, I mean, is this something you generally agree with?
Yeah, no, so I definitely agree with this, Scott. I mean, when we look at cloud and having worked in this space for a while, people really, when they're going to the cloud, they're looking to make things either simpler, easier, or less expensive. So it's a journey. If you're just trying to jump into the cloud, you're probably going to make a pretty large mistake. So definitely, as Scott said, focus on outcomes more than just going to the cloud. So 100% agree, Scott.
And before I continue, I also want to mention that we will be doing Q&A at the end. I want to remind you of that. So if you have questions, please make sure you make liberal use of the questions pane and the GoToWebinar control panel, because we will be taking questions live on the air at the end of today's event. So let's talk about some of the reality of public cloud. There is a lot in the way of perceived benefits when we start talking about public cloud. You know, one of the things we hear about is that there's unlimited scale, at least to a point, although my understanding is Amazon actually ran out of capacity in one of their locations relatively recently. Steve, did you hear about that?
Yeah, in the UK, the micro instances in AWS actually ran out of space, so all the T instances were gobbled up over in the UK footprint. So
there is still lots of scale there, but we talk about sort of this unlimited scale thing, and it's true to a point. When you want to add stuff to more resources to your account in a cloud provider, you can generally do so, although there will be some limitations. You get immediate time to value. And that means, and the reason you're getting that is because you're not having to spend so much time making sure all of your stuff works together. And we're going to talk more about that shortly. And obviously there's these economics. There's this idea that we can basically get started with just buying what we need and then add more as we go along. And we don't have to pay for things we're not going to use. But the reality is you can't just throw all your workloads over the public cloud fence. You know, one of the things you're going to find is you will find a cost barrier. You're going to hit that barrier at some point. And one of the things, the terms I've seen recently being used is called cloud sobriety. And what that means is people are looking at their cloud bills and going, oh, this is getting really expensive. And they're discovering that from a purely financial perspective, it's actually better for them to start pulling workloads back into the private data center environment. They went too far into the public cloud, and now they're paying the price. And one of the things you'll find is sometimes costs can be relatively sneakily hidden. So, and a lot of times this revolves around the exit costs. So if you decide you need to exit a provider, you may find that getting your data out is a relatively expensive exercise. So before you put data into a public cloud, you want to make sure you fully understand where all the potential cost points are, as well as what happens when you try to pull your data out. Steve, what kind of advice do you have for the audience on the issue of cost and exiting a cloud?
So a couple of things with respect to exit. I mean, when you're looking at your clouds, as you pointed out, Scott, there's cost. I would also pay attention to how those cloud providers give you an off-ramp. Some providers have some capacities for off-ramping, and others simply don't. So when you're looking at those cloud providers, check in and dig in a little bit before you jump into that pond on how you can actually get out of it. And like I said, Amazon, they have some ways of getting out. So that's probably one of the key things I would pay attention to if you're looking at off-ramping the cloud at some point in the future.
The other piece of this that we want to make sure people understand is that there's some level of customization available with the cloud. You can buy, small, medium, large, extra large sort of instances, but they're all pre-sized. If you need something that's in the middle or bigger or smaller, you're going into a custom configuration, which is going to cost you much more. And sometimes it can be better just to bring those back to the local data center if you haven't already. And here's the other piece. Not all applications are suitable for the public cloud. I had a client recently who wanted to move their legacy ERP to a public cloud provider. And it was a client server application. And I told them, okay, that's great, but we're going to have to figure out the desktop side, because the problem is there's going to be massive latency between the desktops now and the database server that's going to reside in the cloud. And so the application is going to perform poorly. So we had to start talking about doing virtual desktops or remote desktop services or something along those lines in the cloud provider, so they could continue to access that application in a way that made sense. And so when you start thinking about applications that are going to go into the cloud, you got to make sure you take very much a case-by-case approach and really look at the individual pros and cons of what's going to happen when you move individual applications into the cloud. So the other side of cloud is private cloud. And this term has been abused and misused and ruined, unfortunately, in some cases over the past few years. And the reason is because people think I'm highly virtualized, therefore I have a private cloud. And that is not true. It's not the case at all. Basically, if you are highly virtualized, you are just that. You are highly virtualized. When you start to think about private cloud and some of the features that are associated with it, there's a lot of implications that you really have to think about. There are a lot of characteristics of private cloud that are very important. So when you look at the public cloud, the reason it works is because there's high levels of automation and orchestration happening behind the scenes. Cloud providers have spent an inordinate amount of time making sure that all of the processes that you as a user have to undertake are automated. When you go and you create a new instance at Amazon or Microsoft Azure or whatever cloud provider you're interested in, there's not some person behind the scenes that has to carry out those orders for you. It just happens. And when we think about creating an entire network, all these services are orchestrated. So when you go through the process of creating this virtual infrastructure at a cloud provider, there's not a person having to get involved. And when we start to think about our local data center, our on-premises services, when we think about the fact whether or not they're a private cloud, automation and orchestration are key components of whether or not we can really consider that a private cloud. And the reason is for the next point. We really want users to be able to provision some of their own resources. This idea of user self-service is critically important. We want IT, in a lot of cases, to become an exceptions-based organization where, okay, there's something they're doing that's sort of unusual. That's when we have to get involved. We want to make the routine things routine and automated. So when users need to stand up, let's take a development organization, they need to stand up another few servers for development testing. They should be able to do that through a portal without IT having to be involved. This should also be easy to scale. This is one of the key characteristics of the public cloud. If you want to add more, you basically add more. And on the private cloud side, there's an understanding where you're not going to have the kind of internal scale that Amazon does, but you should be able to add hardware, the underlying hardware components to your local environment without going through a lot of pain. You should be able to just add more storage, add more compute, add more RAM, add more network, whatever it takes, without having to bring things down and without incurring a lot of disruption or any disruption when you do actually scale the environment. So it should be easy to scale the underlying hardware resources to be able to create more workloads as time goes on. And this goes to the issue of elasticity, or at least the appearance thereof. We want to make sure that this is an environment that appears to be as elastic as the public cloud, which means we can upsize or downsize workloads as it makes sense for the business. And one piece that isn't always included, though, is really this idea that we need to understand, individual departments need to understand how much they're costing the organization. Now, this doesn't mean you have to start setting up massive chargeback infrastructure and stuff like that, especially for smaller organizations, but you should be able to say, look, here's how much these sorts of workloads are actually costing the organization. And by doing so, when you start to take those application by application assessments and determine what do you want to do with those, it gives you data to be able to make good decisions. It also helps you understand what the true cost of operating workloads is, so that as time goes on, you can make good decisions about what to do with those workloads. Steve, what are your thoughts about this whole idea of these characteristics of private cloud?
You know, these are great salient characteristics. I think a couple of things that I would add to this when we look at private clouds that we're finding to be important. You know, you've mentioned, you know, chargeback, showback, elasticity, ease of use. A lot of the things that we see in some of the solutions that people put in place is a lack of interoperability. So when you're looking at solutions that are going to be cloud-like on-prem, every single component, just like Amazon or Azure, needs to interoperate. So you want to have some level of interoperability. And then another major tenet with any cloud provider in the public space is tenancy, right? So that's kind of an offshoot of the idea of chargeback and showback, especially in larger organizations. So when you're looking at a private cloud infrastructure, you want to make sure that you have the ability to bifurcate different organizations apart from one another. You want to be able to either do that logically or physically, and that will give you a kind of a true feel of being in the cloud. So I would add those couple of things, Scott, to this list, but this is a great list of what you should be expecting when you're putting together your own private cloud solution.
Excellent. So let's talk about this convergence spectrum that I talked about before, where we talk about the different kinds of infrastructure that we have at our disposal. We have the traditional approach. This is where we take a best-of-breed approach, and we buy servers and storage and networking separately. The problem here is while it's eminently flexible and it's a proven architecture, there's a very high total cost of ownership here, and we have potential for a lot of interoperability issues, which requires us to undertake lengthy proofs of concept testing. And that can be challenging for organizations. So this is a relatively expensive way to go. As we start to look at some of the newer options that are available on the market, this is becoming less popular as an option because it's also relatively complex. And that's one of the things we're trying to get away from in IT these days, is this idea of massive complexity in the data center. We want things to be easy to use. So a while back, converged infrastructure hit the scene. And this is basically a single rack or multiple rack or whatever it happens to be instance where we basically buy a single SKU from a vendor. This is a pre-validated infrastructure solution that often ships ready to go. And if you need more, you just buy more. The nice part here is while with traditional infrastructure, we have to spend a lot of time making it work, this just works out of the box. So we get very fast time to value. We have a single point of support. But it really is based primarily on just new combinations of existing products. There's nothing particularly revolutionary with the way these work. So there's not a whole lot in the way of operational improvements. What we've seen in the last couple years, the last few years, is this rise of hyperconverged infrastructure. And this has helped with some of the limitations we saw with Converged. These are very granular systems that are based on commodity hardware. And if you need more, you just add more. They have a lower cost of entry than converged solutions. And we start to get some operational improvements that we can't get, merely because we're going to eliminate the separate physical management of storage. But the problem is, as we grow, we don't have individual resource complexity, and it doesn't really address the network side of the house. In fact, as we grow, we basically just add more of the same. So if you need more, if you've got plenty of RAM, but you need more storage, you've got to add more RAM and compute at the same time that you add storage. So that's the big drawback to hyperconverged infrastructure. It's great, but it's got these issues as far as scaling goes. And this is where Composable comes into play. And this is going to be really the focus of a lot of what we see later on. This is also very granular, based on commodity hardware, but we get complete resource flexibility. This has a far lower cost of entry than other solutions architectures. We get major operational improvements because even though we're able to manage each individual resource from a physical standpoint separately and grow them separately, we still manage the entire solution as a singular whole. So we get significant individual resource flexibility, and we're also bringing the network into play here. So rather than just keep seeing the network as a place to connect to, we're going to begin to actively manage it in a composable infrastructure scenario. And as we need to add resources, we can add more RAM or storage to what we already have, or we can add just what we need, and we can expand our sphere of management without having to add more RAM and compute, for example, just because we need more storage. So this allows us to really dial in far more granularly on the resource allocation than we can with any of the other solutions that are out there. So we can buy what we need and not have to worry about buying more than we need, while still maintaining this ability to pay as you grow. So this allows us to get far closer to cloud-like expansion than we can get with almost anything else that's out there. We add resources we need. There's no disruption to add those resources, and we can very simply add them when it becomes necessary. So the benefits here are pretty clear. So we get granular and independent resource scalability. We don't get to this linear scalability with its limitations. You get what you need. But the hardware and software still operate as a single entity. This is a fully software-defined solution. So we can use commodity hardware to our heart's content, which helps us further on the cost side of the house. Then we can operate lots of different kinds of workloads, including virtual workloads and even containerized workloads, but it's simple to manage and maintain. And with that, I'm going to turn over to Cloudistics. Steve, I will give you keyboard control.
Perfect.
Take it away.
All right. So we're going to have some additional information around some of the things that Scott's just touched on. So I'm going to go through a couple of these slides really quickly. But basically, like Scott said, when we look at composability and composable platforms, what we've tried to do with Cloudistics is basically give back some of that incremental scale capability that we had with those converged platforms, the first wave of infrastructure, the FlexPods and vBlocks, but reduce the complexity. And a lot of that simplicity that was introduced by those newer architectures that we've seen most recently in the hyperconverged space have introduced a lot of simplicity. But at the same time, a lot of the attributes that Scott has talked about already around, public cloud control and experience, we wanted to make sure that every single one of our customers had that experience. So as we go through this, and at the demo, I'll show you that in our world, everything is interleaved from a software standpoint. And when a user comes in to do things in the platform, it's no longer a matter of, I need to put this virtual machine in this space and worry about where storage is aligned and things like that. It's literally just a matter of deploy virtual machine against the federated pool of resources. So we really want to make sure that when you're doing a public cloud deployment on-prem, your private cloud, that it really feels like that private cloud infrastructure. All right. So Scott's gone through a lot of this already. So when we look at a couple of things that I wanted to add on the I'm not going to say negative, but some things to watch out for when you look at the cloud, the public cloud. A lot of people jump into this and they get into the Amazons and Azures of the world, and they don't think about the level of control or visibility that they have. So if you're a government customer or a healthcare customer, you'll be able to get in and see what's in your space, but you have no clue what's going on around you. And you've seen a lot of that take place today in that ransomware attack. It hit a lot of major cloud providers, not necessarily Amazon and Azure, but it hit. So not having that visibility, control what's going around you is something that you give up when you go to the public cloud. Another thing that we see, and this is where, Scott covered use cases, it's important to look at the envelope around that use case, right? If you're going to do something like VDI or Splunk or a use case that has really either high user touch or high bandwidth constraints, you have to pay attention to what that's going to look like if you move it off-prem. In the case of Splunk, I could be transitioning terabytes of information in every single day over to some public cloud, and it may take multiple hops to get there. In the case of VDI, if your user footprint is way away from the user, you're going to see sluggishness. So you've got to pay attention to latency and bandwidth with these applications. And at the same time, you've also got to pay attention to those costs. And then the last thing Scott talked about, getting into the cloud is generally really low cost. I mean, you can get into an Amazon instance for as little as 12 cents per hour, CPU hour. The problem is that a lot of people get hooked on that early cost model, but when they start running those applications 24 hours a day, 7 days a week, they start seeing some astronomical bills. So what happens is people get surprised pretty quickly when they start adding in additional workloads to an Amazon or Azure footprint. Now, they're reducing costs all the time, but the key thing there is they haven't changed the core basics of how they bill, which is by the hour, and that's going to cause problems with any full-time use case. When we look at the infrastructure lay of the land, I'm trying to get these advanced, Scott, so bear with me here. There we go. When we look at the infrastructure lay of the land, we've talked about cloud, and it's a little known that cloud actually came out before these converged infrastructures. And we've got that idea. When we look at the integrated systems footprint, Scott's already covered the complexity and the slow time to market of the previous converged footprints. And having worked for Nutanix before Cloudistics, I did have the opportunity to deploy a lot of those systems. And by moving into that hyperconverged space and not necessarily paying attention to what we were doing by combining resources together, we introduced some interesting scenarios where, we had some resource lock issues where we were stranding resources a longer time. So I coined a term with my service providers customers of resource drift. And that's just basically where you have stranded resources that basically build up over time. And that's a net side effect of any hyperconverged solution. It's just something that's a side effect of putting all your resources into a single lockable node or unit. The provisioning there gets to be a little bit more interesting because of the way these newer architectures work. So you've got some problems around walking over the edge of certain storage footprints. And then ultimately, when you get into this, because you've got stranded resources, the overall costs of some of these architectures tend to scale up pretty quickly. When we looked at things from a composability standpoint, like we said in the beginning, we wanted to be able to give you a cloud platform on-prem. So it had to be simple. So we wanted to take some of the pages out of the books of hyperconverged and make it really simple, but then add on even more experiences like you would see in Amazon. Scott talked about application specificity. We wanted to make sure that the platforms itself could run any workload. So you'll see in a few slides that we focus on really large and complex workloads as the core things that we're paying attention to. Multi-tenancy is an absolute must for a cloud platform. We talked about that earlier. I'll talk to you how we get through that in another couple of slides. We look at performance. When you get into a cloud platform, and Scott talked about this earlier, we don't think about resources. So you've got unlimited scale, but more importantly, you almost expect that to run at speeds that are, unknown on-prem. So we wanted to make sure that we give you that unlimited scale, meaning incremental scaling points, but also the speeds that you'd expect with high-performance computing platforms. And then lastly, to be a cloud platform, we had to have some way of consuming this with a cloud-oriented economics. So I'll talk to you about that as well. So when we look at costs, and we talk about Amazon, and I talked a little bit about how Amazon bursts up or grows over time. We've done some analysis against a private cloud infrastructure, ours specifically, but you can do this with pretty much any architecture versus Amazon. And as you start doing the math, things get really interesting. As we did multiple use cases with different sizes of Amazon instances, it came out to be about the same. Regardless of what we did, we always came out to be roughly 50% less in any use case dynamic that we put out there. And the reason being is because I could give this solution to my customers either as a purchase or with different dynamics on a utility base. I could get my cost per thing, cost per CPU hour, cost per gig of memory, cost per gig of storage, way down. And that's just, it was an intriguing exercise to go through, but this is legitimately what we see in any use case with any type of mix of Amazon instances. So as you go through this, and if there's time, we can walk through some of the dynamics around this. So complexity. So let's talk about going from complex to simple. When we look at the stack that Scott talked about earlier, the FlexPod or the vBlock, that converged footprint, there are a lot of things that go into this thing. And every time I click the button, I'm adding one more stack of things that I have to manage. It's another interface. It's another point of reference that I have to troubleshoot. It's ultimately a point of connectivity. So every time I add something to this, it just gets more complex. And if you're looking at it from an operating profile, this is probably a person or a skill set that manages each one of these things. The problem being with this stack, and having been a NetApp guy for a decade, when I was doing designs around applications, it was never me thinking about, oh, I have to run Splunk, or oh, I have to run SAP. Let me design around that. It was always, I'm going to walk in and build a FlexPod, and I'm going to jam Splunk into it or jam SAP into it. So we didn't really have an application first mentality. And that's what, a lot of these Amazons and Azures are doing. They're really focusing on giving people the ability to run applications. When we moved over to the hyperconverged footprint, we did do a great job of converging the resources and making things simple. The whole idea around hyperconverged was to eliminate the complexity associated with storage and compute. We still have a network that we have to deal with, so there's still something that I have to pay attention to, and it is a point of contention in most implementations. And in most hyperconverged footprints, I still have hypervisors that I have to deal with. So, we've got still three things that are interacting that are not seamlessly integrated. And, in these hyperconverged workplaces, we're still talking about an infrastructure architecture that's not focused on applications. So outside of VDI, when you do a Nutanix deployment or an HP deployment or a HyperFlex deployment, you're really just building another architecture that you're going to try to jam an application into. So applications in this scenario, still second-class citizens. At Cloudistics, in order to give our customers the ability to do a pure on-premise cloud, we took the approach of saying, okay, all those components need to be packaged and interlocked together with software. So Scott said earlier, it's software-defined. We basically say that we're software-defined everything. So in that platform, and I'll talk through these on the next slide, everything is software and everything is interlocked together. So you've got control points that span, your storage, switching, and compute that make it such that they act as one body. We've also added the idea of having the hypervisor heavily integrated in this. To do the type of control that we're talking about at the network level and storage level, I simply couldn't just bring in VMware or Hyper-V because they don't let me do things like rip out their IP stack. So we opted to go with Red Hat and using their version of KVM and have dramatically modified a lot of the things that go on around IP technology and storage technologies to make that interoperation happen. So we've done some great things around making a hypervisor an active router in a network. And then lastly, when you look at the way we actually manage this thing, just like Amazon, we separated the brains of the platform from the platform. So for customers that want a true kind of SaaS-based experience, the portal or the management plane of this thing actually lives in Amazon. We've containerized this footprint. We're using Docker containers, so it can be moved anywhere. And that footprint lives inside of Amazon. Highly available, highly distributed. And by doing that separation, we give the customers the ability to have visibility of any platform anywhere in the world. Now, if it needs to be more secure and on-prem for my government customers, healthcare customers, or finance customers, or anybody that needs additional level of security, that container can come back on-premise and behave just like that. It will just live in a footprint that we provide to you on-prem. But by doing that, the other thing we added into that brain is a marketplace. So every technology alliance partner that we work with, we work to integrate their applications into the platform. So when you come into our world, you will see and have the ability to download pre-tuned, pre-orchestrated templates for Splunk, Hortonworks, Cloudera, Hadoop, Citrix, and so on and so forth. And what we've done is taken the time to make sure that those applications actually run well in our footprint. And we've designed it in such a way that allows that to happen. When we look at what the platform is, and this is what people ask all the time, what is it, Steve? And I tell them today, it's a combination of hardware and software. If you're a hardware guy and you're looking at this, you notice that it's based on Dell parts, and it's only parts by name and sticker only. When we get these components from Dell, and we're an OEM partner with Dell, we basically whitewash the entire platform. So the operating system, the BIOS, everything comes from us. The only thing that Dell is providing is power, fans, and wires to make things work. When we look at it from a stack standpoint, standard ONI switches, FX2 servers in the middle, and FX2 servers with storage sleds, all flash beneath. As I just said earlier, this is all software defined. So when you look at this from an interconnectivity standpoint, the switches are running a portion of our product called AON, which is an adaptive overlay network capability. And that also runs in the hypervisor. And by doing that, all of the components in our world are active routing participants in a zone. And that does two things for me. One, I don't have to worry about any messy networking protocols. In this world, you don't have to worry about any layer 2 networking protocols. Everything's done at IP. And two, because I've got routing going on everywhere, and we're managing that inside the platform, I've got full east-west control and full north-south control for full microsegmentation across the platform. And then when we look at the storage to server connectivity, we've taken advantage of some of the code that is available in open source and modified it dramatically to make it such that in our world, a virtual machine, when it's addressing storage in this platform, actually doesn't have to worry about a file system stack like in a hyperconverged footprint. It actually directly accesses block storage, which makes it such that it's extremely fast. So we can handle large workloads that would be associated with big data and things like that. But by those interlockings, we've made it such that that platform is tightly coupled together. And then by adding in that cloud management portal, which I'll show you during the demo, it makes it such that anybody can use this, because all you have to do is deploy a virtual machine, and it's that simple. After you get past the hardware, and we don't really pay attention to hardware after we do the initial install and build, which takes about an hour, we look at things from a resource standpoint, just like Amazon. So when you're operating the platform, I'm going to pay attention to pools of storage, pools of memory, and pools of CPU. And by doing that, I don't have to now worry about where something's going to go or how it's going to behave on this particular computer or that particular piece of storage. The platform takes care of that for you. So there's a lot of algorithmic control there and a lot of heuristics that go on in doing all this placement. And from a storage standpoint, everything's thin provisioned, everything. And that gives you the ability to have dramatic controls and pointers and making things really, really fast. We talked about composability being independent scaling. So as you can see from the original picture, storage, compute, and networking are all unlocked from one another. So in this environment, unlike the hyperconverged footprints, I won't have that drift. So I can scale each one of those components independently of each other, and it gives me a lot of capabilities around, being able to incrementally scale these things. And as we talked about, the storage footprint and the network is all non-blocking, which gives us the ability to run workloads at full speeds, which gives us the capability to focus on such, workloads such as Splunk and big data. And then the last thing that comes with this payload and is important to a private cloud is tenancy. The way it was designed, and because all the software is interlocking, it gives us the ability to actually create physical tenant boundaries inside the platform. So I can actually say these 4 ports, these 2 computers, and this block of storage is going to be in a physical tenant boundary. We call that a migration zone. And those resources will never be touched by anything else outside of that migration zone. Inside of those zones, we have the ability to create logical tenants as well. So you can create as many as you want, and the only boundary you have there is how many resources you committed to that initial zone. Every resource can be oversubscribed, just like in Amazon. So you can have it to where you can use cores straight one-to-one or oversubscribe them. Memory can be oversubscribed and storage can be oversubscribed. That can be done both at the zone and at the VDC level. So by doing this, and by adding in the RBAC capabilities that we'll have coming out this summer, you'll have both the full tenancy capabilities, and to Scott's point earlier, you'll have the ability to do departmental level self-service and self-administration to where you can be assured that tenant number 1 will never touch tenant number 2, but more importantly, tenant number 1 will never impact tenant number 2's operations because they are a separate set of resources. When we look at ease of use, if anybody on the phone has ever operated a FlexPod, that's a FlexPod. You've got complex cabling, you've got, UCS manager interfaces, you've got SSH interfaces, and you've got all the NetApp interfaces. It's just a lot to work with, and you've got to be pretty good at what you're doing in order to do this. So this is probably 2 to 3 people that you're working with to get this done. We've said that's not the right way to do things. We want to take all that and put it into one interface. So this interface, the Ignite interface for our platform, allows you to do all the hardware management, lights out, so it's coded into Dell's iDRAC. You never have to touch another piece of hardware again, and you never have to bring up an iDRAC interface ever again. It's all done in this interface. But remember, we don't want to pay attention to hardware. Once it's up, it generally doesn't fail. So when we look at the interface, we're going to really pay attention to, you know, the virtual machine creations and VNets and things like that. And most importantly, we're going to pay attention to the marketplace. And this is where you can get access to our pre-rolled templates and literally take an application that's complex like Splunk and get Splunk up and running in a matter of just minutes. We have one partner that we work with that sells a big data package, we'll call, and it's based on Hortonworks and Hadoop. Their original setup time for just basically server from rack to computing, you know, doing their data models was a little over a week. So we'll call it 5 days. In the Cloudistics platform, once we actually rolled their templates, we added their software plus all the other pending packages, takes about five hours now. So, you know, they get all the models and linking and stuff like that. But it's made it so that they can dramatically reduce the overall time it takes to deploy the application. And that's because we've created an application profile for that application. I'll show you that in the demo. When we look at applications, so we talked about flexibility, right? So in an environment where nothing's pinned and I don't have to worry about where resources are coming from, that gives you natural application flexibility. But the key thing to flexibility is being able to run the biggest and hairiest applications in an environment where you can run the smallest and simplest applications as well. So in our world, we've focused on those big ones. So Hadoop, Hortonworks, Cloudera, Splunk, and containers, and really focusing on making sure that we can tackle those. Our platform is 100% Docker compliant, so any container that you compose in our footprint will be automatically capable of moving to Amazon or any other container compliant footprint, and we're capable of supporting Kubernetes and Swarm right out of the gate. So you've got the ability to do all those things around containers, and you know, if you want to do something around big data on the same platform in another tenant zone, you could do that. Spin up a big data tenant zone, and you can have Hadoop running side by side with the container footprint. The reason we're comfortable doing that is because of the way we address storage and the way we address networking, and we know that that big data footprint's never going to really step on that container footprint. Now, we say in our company that if we can do fast, complex, and really performant, then slow and simple are pretty straightforward. So general server virtualization is pretty easy, and you know, we've got Citrix certified architectures that you can put in place as well. In this particular instance, a customer example that we have is we've got a service provider that provides legal services. And there's one application they use, it's called Relativity. That application is heavily reliant on SQL Server. And when we went in to do the bake-off with their existing configuration, which was physical machines versus our platform, we had one virtual machine running the same SQL Server instance that was half the power of the physical machine. Once they ran the benchmarks, when we came in, we got the traditional, this is going to be interesting. The results are interesting. So we thought we were in bad shape. They basically showed us that our virtual machine, our little virtual machine, outperformed their physical machine by 8 times. And that's a combination of how we do things with the glue of the software and the fact that we're using all flash underneath the covers. So you can get those types of control and that level of application flexibility in this platform. The last thing that we promised you before I jump into the demo is economics, right? So with any type of platform like this, you have the scale up, scale out capabilities. You're going to be able to buy small pieces at a time. So no more monolithic purchases of large filers, no more monolithic purchases of 30 or 40 computers. Here you can buy a computer at a time, you can buy a small chunk of storage at a time, and because it's all managed through that interlocking set of software, once it comes in, it's detected and automatically set up and integrated into your pools. So you don't have to worry about going, oh, how do I get this integrated? Do I have to do any scans? Do I have to attach it to a cluster? It basically identifies itself as a resource. You tell it which pool you want it to go into or which migration zone you want it to go into, and it's up and running. We had that same customer that had the database footprint needed to have 2 more computers added in for additional computational capabilities around that database. We had 2 computers in and live in 5 minutes. So they basically quadrupled their core counts and memory in the span of about 5 minutes, and all they had to do is plug them in and add them into the migration zone. That's cool, right? You can do that, but more importantly, to be a cloud, you have to have a consumption model that allows you to be a cloud. So in our world, we've also come up with a consumption model that's available to any customer that behaves very much like Amazon. So if you want to get into a utility model where you pay for what you use, we have programs that will allow you to get in and commit to resources. You can commit to basically two axes, time and resources. The more you commit to on either one of those axes, the lower the cost for the resources. We charge basically in that scenario for gigabytes of memory allocated per month and gigabytes of RAM allocated memory and disk per month. So that gives you the ability to actually get in and consume very much like Amazon. So kind of summing this up before I jump into showing you guys how this works, it's a complete platform. And you'll see once we jump in the interface, literally don't have to touch any pieces of hardware at all. We try to take the hard out of hardware. It's simple management. The interface manages everything. You get in and you literally don't have to think about anything but deploying virtual machines. Disaster recovery, single click. When we get into the flexibility, we've seen that I can handle those larger workloads and the small ones. Tenancy is core. High performance, we can show that to you in any type of demo scenario. We've got the incremental scale components associated with the different pieces that you can buy at a time. And then if you need it, the cloud economics components are there for you. So that's the last slide. Usually here we would ask people, you know, to take a quick run or a test drive. So what I'm going to do for you is actually do a live test drive right now. So I'm going to work to share my screen here really quick. And Scott, I might need some help here.
Yeah, I just made you the I'm just making the presenter. You should get a prompt.
Okay, cool. Show my screen. All right, let me get into the demo here. All right, so basically what you've got when you come into this footprint, and I will run through this really quickly. I'm not going to go through an exhaustive demo for you guys. I'm just going to show you a couple of things up really quickly. Everybody seeing the screen, Scott? You're seeing the screen, I hope?
Yep, I see your screen.
Okay, so basically when you're in this interface, the first thing you're going to do is see a dashboard. So if you have multiple sites that you're managing, this dashboard is going to show you all the sites that you're managing all over the globe. And it's going to give it to you in terms of resources. So, you know, when we're looking at this, I want to pay attention to, you know, how many cores, how much memory, what my pools look like across this thing, and how I'm utilizing them. So this is an important, you know, just heads up dashboard. If I have any alerts, they'll show up here. And this really gives you the ability just to basically drill into anything that you want to do. We have a couple of core constructs that I talked about before. The migration zone is that physical boundary, that physical tenant that we talked about. When we look at that, if, you know, from a rough construct translation, you could think of this as a cluster. In our world, we don't have clustering. It's not clustered together. The migration zone and all the interlocking software creates this boundary that works together. So if you're working to translate, this is basically the idea of a cluster. But for us, it's really just a pool of resources, storage, memory, and compute. When you look at the other underpinning constructs, I'll talk about VDCs in just a second. In our world, as I said earlier, we don't do any layer 2 scenarios in this platform. So everything's done in layer 3. So really, at the end of the day, when you're looking to do networking, both microsegmentation and full network routing, you have two options. You can create a private VNet that is east-west traffic, and you can create a public VNet that's north-south traffic. And when you're creating these things, it's as simple as basically saying, set up a network. You name it, you put in an IP address range. Every one of these things has a DHCP microservice that runs on it, and you basically just set up the parameters of which VDC it's going to live in. That's that logical tenant. Which storage pool it's going to go, because remember, tenancy has to go all the way down to storage. And then ultimately the zone it's going to live in. Once I do all that, I can apply some firewall rule settings, and away we go. I mean, and I will set up a virtual network that can then be applied to any virtual machine that's running in that VDC. The beauty of that is that is a logical network, and it's not assigned to any particular machine. It's spread across all the routing components that are on both the hypervisors and the switches. So when we look at, you know, firewalls, we have layer 4 firewall capabilities that are built into the platform as well. Same deal. You can set up firewall rule sets that are fully distributed in here, and assign it to either a VNet, to an application set, so we can actually have the ability to say, these groups of VMs are finance VMs, and I'm going to apply specific rules to them, or to pools of computers and other types of assets. So the cool thing there is no longer do I have to worry about, did I change the access control list on the switch? Did I update the IP tables configuration on this particular machine? You come in here and set up one master set of rules that will spread across the entire breadth of your cloud platform. And then it's really managed through, the virtual data center, the VNets, and ultimately application pools. So it's kind of like Amazon, right? You're really not thinking about what it's sitting on, what piece of hardware it's attached to. It's really meant to basically eliminate those things from your point of view. If you do need to look at hardware, you can get into it. And as I promised, we do all of our hardware reviews at a higher level, but ultimately you can get into each one of these components down to the iDRAC level. So when you're in here, you will be able to go and actually console to the equipment. You'll be able to force start it, restart. These are all lower level server type activities and lower level storage level activities. So you can do all of these things from this interface. So no more iDRAC thick client on your computer, no more managing it with any type of lights out manager. This is all done here. We did this design specifically to make it so you could have very much a cloud-like feel, even with managing your hardware. For some of my government customers, they're interested in basically the analytics associated with the facilities. So you can see in real time what your computers are consuming, if that's important to you. When you go into the logical constructs, we're basically going to have the idea of these VDCs. So those are logical tenants. And these VDCs are allocated resources, basically just like the migration zone, except these are associated with a migration zone. So in here, you're going to have virtual machines, you're going to have VNets assigned to these VDCs, firewall rule sets potentially assigned to the VDCs. But just think of this as a logical tenant boundary within this particular cluster. And what that does is it says this tenant has these resources and nobody else can touch these resources. They're dedicated and predicated to this particular tenant. And then from there, you can do things like tenant, you can do snapshot recovery footprints at the VDC level. You can look at all the resources that are being consumed by this VDC. And you can really look at the metrics that are this particular VDC it has around it. This is important to Scott's earlier idea around chargeback and showback. Now, because the platform is capturing all this information, I can go in and now through, by exporting information, I can actually see what this particular customer or this particular organization in your company is consuming. So you'll be able to see that in real time, and you'll also be able to see that in exported CBS files. So when we look at the VDC itself and look at the virtual machines, you can see all the virtual machines running. I want to take just 1 second to show you the marketplace. And this is where we have all of the rolled applications that we support. So you can see here that we have, a lot of different services here. This data adapt application is that one I was talking about earlier with one of our partners. That is a multifaceted application that includes Hortonworks, Hadoop, and some special sauce from our customer, our partner. And this guy is their big data platform. So this is by doing this and presenting it in the marketplace, and we publish this to all of our customers now. They have the ability to actually not only sell their product to other people, but actually actively provision it from the marketplace. If you are using the marketplace and you see something in there that you like, you just say download, you bring it down to your local instance, and away you go. So you can see we've got Docker, Splunk, Data Adapt. We've got a lot of other microservices in here. But as we bring on more taps, we'll be adding more footprints to this marketplace. Setting up and spinning up virtual machines is really simple. So when we go over here, if we want to deploy a pretty simple instance of Splunk that doesn't give me any major controls over whether the affinity of the Splunk instance, whether it's a search head, a forwarder or an indexer, we can set this up and simply just say, I want to come in and change a couple of parameters on this particular template. And you notice, I'm not saying where I want it. I'm just saying I want it in this VDC. I want it to be working with networks. I want it to be assigned to the networks that are in this particular one. You can have multiples. And I'm going to apply some firewall rule sets to this particular set of virtual machines. I pick a storage pool because once again, remember everything's multi-tenanted. And I can change, a couple of these statistics as we're going down. And I can change anything I want to with respect to the names of, the types of core footprints, and ultimately the migration zone. In this case, once I pick a storage pool, I'm locked into my zone. So I've got full tenancy with that capability. I can tell it the number of instances I want to create. So I'm going to create 5 of these guys. And I can, in this particular instance, I'm going to assign it to my Splunk group, just in case I have any Splunk related rules I want to apply to it, and hit create. And it will go off behind the scenes and just start creating those 5 instances for me. When we look at these instances, and we're almost done here, I'm going to basically show you 2 last things just to show how easy things are. So you notice when I created those instances, I didn't have to tell it where to go, what type of storage to consume, what machines to go on, what type of working group sets I had to work with. I just said deploy virtual machines. The same thing is in play for snapshots, right? So for this particular machine, if I want to take a snapshot, I can just take a snapshot and I'm done. Or I could say turn on snapshots, and I want to make them automatic, and I can do that here. Today, the increments are down to 15 minutes, and the revision to code that will be out at the beginning of June, it'll have full user control, unlimited number of snapshots. So we're basically going to let you guys have full control over how many of these you want to have in place. And all you have to do is basically turn on snapshotting. Now, snapshotting is a prerequisite for DR, but DR is just as simple as snapshotting. So what we've done with DR is made a single click. You can deploy this to any additional foreign storage pools that you have. And here, what it gives you is the ability to not only do snapshot recovery, these daily snapshots, but we've also built in some backup capabilities, basically giving you the ability to have retention policies, yearly, weekly, quarterly, monthly type of scenarios, and build that into your snapshot retention footprints. These things, once they're done, actually will be full snapshot capables on the DR. So not only can you rehydrate them, but you can actually spin up additional virtual machines off those snapshots. So it gives you the full capability of not only just recovering, but also creating new virtual machines off those snapshots. So Scott, I'm gonna kind of close it there. I mean, this gives you guys a pretty decent view of how easy it is to work in this environment. I guess the last thing I'll do is support. Support is, in Amazon, if you guys have ever worked at Amazon, Amazon support is challenging. In here, we've given you 3 options for support. Obviously, you can pick up the phone, and we have a lot of millennials we work with today, and I'm an older guy, so I tend to pick up the phone, but I know a lot of my friends that are younger than me like to do text and instant messaging and things like that. So in this world, you can instant message our support people and get instant response. If you want to go the old traditional, I'm going to send my logs to you scenario, you come over here, and instead of having to collect the logs, FTP them down, do all that stuff that would generally happen, you just go over here and say send system report. That will send over to our support team a full set of logs for storage, networking, and compute components, so they can actually analyze any particular problems you're having. And this is the piece I like the most. When we want to have them take control, I can turn support mode on, and what this allows me to do is get keyed sessions, and allows me to have a reverse proxy set up to where the support guys can come in and actually take control and work with me to solve a problem. Now, the cool thing is you have complete control over this. So if you don't like what's going on, or if you think that you need something, that it's time to end this, you can go back and say in support. And what that will do at that point in time is turn off the tunnel, and you're done with your support session. So I'm going to stop there, Scott. I know we've got time for questions. Hopefully that was, not too long. I wanted to give people a good run through on this demo.
Perfect. Well, we have this screen. Yeah, run back. We have a couple questions for you. The first one is how does Cloudistics provide tenancy isolation?
So there's 2 ways to do tenancy isolation. So when you look at it at the physical level, we basically are doing logical boundaries of resources. So we're basically saying inside of the networking modules at the hypervisor and switch footprint, that those pieces are allocated to that zone. And then at the storage level, it's an entire storage block. So a block is two computers that act as controllers and the actual disks that go underneath it. And you can't bifurcate that any further than that. So we don't want to have any bleed over from block to block. So at the physical level, it's the physical assets tied to that particular zone. Inside of the logical footprint, the way we do that is by using networking. So just like you would with any type of multi-tenancy, because the networking boundary extends from the switch ports with that AN footprint all the way down to storage, we have the ability to basically say this tenant boundary is locked in based on this networking boundary that we create inside of the platform. Without the control from switch to hypervisor to storage, we wouldn't be able to do that. And that north, south, east, west microsegmentation is how we achieve that particular tenancy. Tagging, we can get into tagging and other conversations that allows us to do grouping that you would expect to see in something like NSX. It's simple to do. Is another way to add some additional tenancy capabilities. And then all of the plumbing for RBAC is in there. We're just working to enable RBAC in both our off-prem and on-prem portals, so we can make sure that everybody has that. But that's the basic constructs. I can get an SE to walk you through the really gory details if you guys need that.
I think you already went through this one, but do you provide tools to do chargeback? And I believe you said yes, and you showed some of those, correct?
Yeah, so the tools today are exportable. In the future, we plan to have show me my bill inside the GUI. But today, it's an exportable file that will give you granularity to the minute per resource, per VDC.
And that's the time we have. On your screen, you should see some how to get started resources for Cloudistics. You can schedule a technical session or do a low-risk test drive. You can do cloudistics.com/virtual lab or email sales@cloudistics.com. Is that accurate there, Steve?
That is correct.
And we have one more piece of very important business to take care of before we end today, and that's to give away one of the new Samsung Galaxy S8 non-exploding cell phones. And this is the edge-to-edge device. It's actually really pretty. I saw one last night. And our winner today is Tony Dvorak. We'll be reaching out to you after the show, after the event, with information on how to claim your winnings. Steve, thank you to you and the Cloudistics team for being here today.
Thanks. I appreciate the time, Scott.
Thank you to our audience for joining us today as well. Everyone have a great rest of your Thursday.